Morning, everybody.
Good morning.
So do we have all three speakers at the SAAO? I know Kenda is there. What about Unati and Maram Kaire?
Niruj, we're going to start anytime. We are ready. Yeah? You can just.
I was wondering whether all the speakers are there. All the three speakers are there in person.
Yes, most of the people are here in the person. Yes, we are ready to start. Just
Okay.
go ahead and.
So let's give it 2 or 3 minutes. We can start. We only have 15 people here so far. Let's give it a couple of minutes.
Niruj?
Yeah.
We're ready to start anytime. Just go ahead. Just
Okay.
okay. Let's go ahead. Huh?
Okay. So welcome everybody to this plenary session, which is session number 10 on the third day. We have one science talk and two outreach talks by Kenda Knowles, Unati Kondile, and Maram Kaire. The first talk will be by Kenda Knowles from Rhodes University in South Africa, and she's going to tell us about a lot of work she's done recently, which you might have seen in the newspapers because it got a lot of press, media attention of using Meerkat to study galaxy clusters and then to map out clusters, and all these beautiful images you saw in the media basically comes from her work. She's also the L'Oreal UNESCO for Women in Science Sub-Saharan Africa postdoctoral fellowship, and so her talk will be on viewing clusters with Meerkat. Kenda, please. You have 25 minutes, which is 20 plus 5. And I will remind you at 20 minutes to kind of start winding up.
Okay, great. That's perfect. I just want to check that the people remotely can hear me. I'm assuming a yes.
Yes.
Okay. Well, thanks very much, everyone. This is my first 3D talk experience since 2019. So happy to be here. So yeah, I'm just going to talk to you today about two projects that I've been involved with and part leading with Meerkat, focused on galaxy clusters. So I know not everyone is necessarily a cluster expert. Just make sure this is changing. Yeah, okay. Is that easier for people? Okay, it's easier for me as well, just checking. Right, so for those who don't know much about clusters, what I'm showing here is a beautiful composite of the bullet cluster. Obviously in the color, the sort of the whites, the oranges, you can see all the galaxies, some foreground stars. The dark matter mass distribution from gravitational lensing is shown in blue. And then the X-ray, so that's the thermal ICM, is shown in pink. So getting a full multi-wavelength view of clusters is really important to understand the full physical environment. And when you add radio to it, you can often see things that you can't see in any other waveband. So here the radio is shown in green. And here you're starting to probe the non-thermal intercluster medium, as well as cosmic ray electrons and cluster magnetic fields. So keep that in mind for the rest of the stuff I'm going to talk about. So as I've said, the view that you have of clusters is dependent on the waveband in which you look at them. But in order to look at a cluster, you need to find it first. So there's a variety of different wavebands that people have typically, searched for clusters. Optical and X-ray being the most sort of long-lived ones. And optical and X-ray are really great because they can tell you something about the dynamical state of the system. So clusters, structure builds up in the universe through mergers of smaller structures, so major mergers, minor mergers. And this a merger leaves a trace or some sort of signature on the cluster itself. So for example, in the optical, you would maybe see a merger through multiple BCGs. You can often find different optical substructures if you have a pre or near post-merging system. X-ray, in the thermal intracluster medium, you can see things like shocks, turbulence, often like you can see in this central image. But the problem with those two is that they tend to be redshift limited. So there's an alternative to go through the Sunyaev-Zeldovich effect, which is a inverse Compton scattering from the CMB, and that you can detect clusters through their decrement in the CMB. So our ground-based observatories and Planck as well, they have generally poor resolution compared to X-ray. So you can't generally tell anything about the dynamical state, but the SZ effect is really powerful because it gives you a mass-limited sample with which to do really good statistics on any sort of cluster studies. So some of the work I'll be dealing with today is based on SZ cluster searches. So, okay, great, we now know how to find clusters, but once you've found them, what can you do with them? I'm just showing a small sample here. It's by no means a sort of an extensive list, but there's things like looking at the actual individual galaxies. So looking at bent-tailed sources, this can tell you something about what we call ICM weather. So again, linking to merger activity, dynamical activity. In clusters, you can start their, very dynamic environments, very extreme environments. You can start looking at the environmental impact on things like star formation rates. There's AGN feedback, magnetism. As I said, radio gives you some insight into the magnetic fields. But the thing that I'm going to focus on is what we call diffuse cluster radio emission. So what is that? In that initial image I showed you where the green was showing the radio, you saw the sort of the fuzzy region that came up in green. That is something that we call a radio halo, and it's one type of diffuse cluster emission. So the diffuse cluster emission is generally large scale, so it's anything between a few hundred kiloparsecs to more than a megaparsec. And what you're seeing is synchrotron radiation that's pervading over really large volumes, which means because of the electron decay time, you need some sort of in situ acceleration mechanism to keep the electrons at near relativistic speeds to produce the synchrotron. So all these different characterizations, they sort of are defined by where the system is in the cluster. Is it centralized? Is it on the edges? How big it is, its shape, and whether it has any observed link to specific galaxies. So typically diffuse radio emission is not galaxy linked, it's actually linked to the intracluster medium of the system itself. Most of the studies for this have been focused on nearby very massive systems, because this is where you expect to have a lot of dynamical energy available to keep these electrons up to speed. So what we know about them is that all of these systems, all of these types rather, are faint. They're steep spectrum. So the synchrotron, you have your power law spectrum. These are quite steep, and they were typically thought to be quite rare. There's still a lot of questions, a lot of it due to the fact that we haven't really been probing statistical samples outside of the nearby massive systems. So we still have questions about how do these systems change at higher redshift? What is the mass dependence on their formation or expecting them to even occur? So these are some of the questions that we're wanting to start answer. And Meerkat is a really good instrument for this because of the actual array design. So first off, it's extremely sensitive. It was built so well, it was more sensitive than what the astronomers were asking for, which is always a good bonus. But it's a fixed array, so the dishes, they don't move like the JVLA does. But when they designed the array, they had a setup where you had a very dense core. So with radio, if you're not familiar, short baselines basically translate to sensitivity to large stuff on the sky, and long baselines, so that where baselines are separation between the two antennas, that gives you the resolution, so being able to find fine detail. And Meerkat has a really nice balance between these two, with about two-thirds, I think, of the array are in this 1 kilometer core. And this means that it has exceptional sensitivity to faint, large-scale stuff on the sky. And that's exactly the type of structures we're wanting to probe with diffuse cluster emission. But the problem with diffuse cluster emission is that it is very faint, and you always have radio galaxies involved. And now if you have too poor a resolution, you're just going to have blending of those galaxies. So how do you disentangle radio galaxy like AGN emission from this diffuse soup that you're trying to probe? And that's where the resolution comes into play. As at L-band, you get about nominal 8 arcsecond resolution. You can do slightly better depending on your imaging. But with 8 arcsecond resolution, you can disentangle compact emission from the diffuse emission all the way up to redshifts of about 0.8 to 0.9. And yeah, so L-band was what was originally available. Obviously, UHF is now available as well. It's lower frequency, so these steep spectrum sources should be easier to see. So the first project that I want to talk about is mergers. So it's the Meerkat exploration of relics, giant halos, and extragalactic radio sources, because astronomers love their acronyms. And the main point of this project is to perform a statistical study of diffuse emission in these ranges that have not been probed before. So that's the high redshift and the low mass. Because using a well-selected sample where you understand the selection criteria and any biases in your selection, you need to do that. You need to know those details in order to do a robust statistical study. So for this project, we're wanting to observe about 200 clusters to get enough statistics. We're using the ACT-DR5, so that's the Atacama Cosmology Telescope. It's an SZ instrument. So again, it's giving us a really nice mass-limited sample of clusters from which to pull our targets. The one sort of note about this project, at least in the beginning, is that in order to observe that number of clusters with Meerkat in the lifetime of Meerkat, we're expecting to need short integration times. So this is sometimes a challenge with radio observations, because the less time you have on the telescope, it affects your ability to basically get back an accurate model of the sky that you're observing. I won't go into all the technical details, but if the radio people out there, your UV range and your UV coverage, which is your basically what it translates your telescope response to a point source. If you have really scrappy UV coverage, you tend to get side lobes, and then it becomes very difficult to recover a nice, clean image afterwards. So we did a pilot project to start with, just to basically test the observing strategy. So the two things we wanted to check was, can we deal with these short integration times and still manage to get a good image back? The way we did this was to, instead of taking one observation of an hour, we split that into, let's say, 15-minute blocks and spread them out over time. And then also just to check the sensitivity. Can we actually find diffuse emission with the sensitivity of Meerkat in short integration times? So I'm happy to say, yes, we can. The project was a success. We had a 70% detection rate. The one caveat with this project was that it wasn't a statistical sample. It was only 13 clusters. And we did bias the sample towards candidate mergers, where you'd expect to see the faintest structures, the largest, faintest structures, which are radio halos. So there's still lots to do with this project. One of the things that has been being done is to now look at this multi-wavelength aspect. So combining the radio with X-ray, optical. We also have the SZ information, and trying to get a holistic picture of specific individual systems. So this is some work that was led by a master's student at UKZN, and basically, again, a proof of concept that we can actually start probing the individual systems. So after the pilot project, we asked for the first main tier. This data was finished observing in December last year, so processing has just been completed. And so we're busy in the analysis step, but it's really nice to see that we are picking up new sources that have never been seen before. And some of the sources that we're picking up are a bit confusing. And confusing is always good, because it makes us look further and try and understand what's happening. So of the 21 clusters we observed, 10 of them have some sort of diffuse detection, but I don't have main results to show yet, hopefully in a few months. Then the last one that I want to talk about in my last sort of 8 minutes or so is a very, very big project that took about 2 years, 2 or more years of my life. It's an observatory-led project called the Meerkat Galaxy Cluster Legacy Survey. So this was 1,000 hours of Meerkat data that was taken over about a year, 2 years. It's 115 cluster targets, all observed at L-band. And the difference between this and the previous project I spoke about is that these are long track observations. So each target was observed for at least anything between 6 to 10 hours on source. So these are beautiful, deep, deep images. So also for the details, everything was observed in full polarization. The data release that came out last year, only about 40% of the systems have full Stokes images. The other caveat with this sample is that it was a heterogeneous selection. So obviously Meerkat was already starting up a lot of the large survey projects. So targets were selected from sort of 2 larger samples, a radio selected and an X-ray selected, but targets were chosen to fill gaps in the observing schedule. So you do have nicely well-selected subsamples, but not the full 115. And as you can see here, that they are mostly low redshift systems. So the main sort of general capabilities of the survey. So I should first state that the legacy survey, I mean, it's in the name. It's meant to be a legacy survey. It's meant for the community to use for whatever they can dream up for their science goals. So the data release is public. So what can you do with the data, the images that we give you? So first of all, I've mentioned this earlier, there's a sensitivity that Meerkat gives you on many scales, sensitivity to large scale stuff, but also decent resolution. And because of the sensitivity on many scales, you can do filtering techniques on the data. And in cases like the one shown here, where there is diffuse emission in that cluster, but in the middle panel or the first panel, it's very difficult to see. And when you just, from the first to the second, you're just smoothing out the map. So that's generally what you do to try boost sensitivity to large-scale faint stuff. But because you have such great point source sensitivity, you get blending, and you get very confused between, well, what's compact emission, what's the diffuse stuff I care about. And the filtering technique can actually help pull out the diffuse structure, which is seen in the third panel. Then also because these are nice deep images with Meerkat, and Meerkat has a wide bandwidth, you can actually do in-band spectral index studies. So typically for radio observatories, if you wanted to study the spectrum, you had to go to either different observatories or at least different frequencies with the same instrument. With Meerkat, for intensities of about signal to noise of 10 or more, you actually have enough sensitivity within the band to do this, split the band in 2 or multiple, and actually investigate the spectrum that way. So this is a really nice spectral index map of one of the tailed radio galaxies. So you're seeing both the compact and more diffuse emission that we can start probing the electron populations. There's also some H1 science, which I won't even mention today, but there's been a really nice demonstration in the paper of commensal H1 with a study that was designed to be continuum. And then, as I mentioned again, we do have polarization there's polarization images for about 40%. And so here you can see a rotation measure map of one of the really big diffuse sources in the sample. So this is just a sort of a highlights reel of some of the things we can do. Obviously, diffuse emission, that's something I'm very interested in. We got, not all of the clusters were brand new. Some of them had been looked at before. So we have systems where we're now getting a different picture of systems that had been studied before. So, just new details about a system that we thought we knew everything about. And then we have other systems I can see in the lower left corner that really just don't conform to any sort of classification that we know yet. So those are really interesting things to study to try to figure out what on earth is going on. And then moving away from diffuse emission, there's also so much science you can do with the actual radio galaxies. So, we're seeing beautiful magnetic filaments. This is Abel 194 in the top right. All this beautiful diffuse structure, but these also filaments coming out from the jet. We also have examples where we're seeing really strange systems again, where we need to try to disentangle, are we looking at one source, or actually looking at a superposition of several? And then there's some paper references there. Then again, you can now look at, there's been some work done on star-forming galaxies. In the survey paper, it was able 209. This work has been continued by a PhD student looking at a larger sample of the MGCLS clusters. But the nice thing about this is that we've shown that we can start probing star-forming galaxies out to much larger radii than have ever been probed before in the radio regime because, again, of Meerkat sensitivity. And then the last thing I want to mention is looking for high redshift radio galaxies, which is not necessarily anything to do with the cluster, but it's something that you can use any sky observation with Meerkat for. We took one of the cluster fields, did a high redshift radio galaxy search, cross-matching with optical and infrared sky surveys. And again, because of the in-band spectral index, we could actually institute the spectral index cut that's often used in HZRG searches. And we did. We found over 200 possible candidates, which would need to be spectroscopically followed up. But again, our spectral index coverage was complete above 0.3 millijanskis, which is about an order of magnitude lower than has been probed for high redshift radio galaxy searches at this frequency or scaled up to this frequency from previous studies. So again, very promising data set. So I think I'm on time, hopefully. But I just want to hope in this whirlwind talk, I hope I've convinced you that, Meerkat is very well suited to studying faint diffuse sources, even if you have short observations, but that's not the only thing it can do. And with a single data set or single observation, there's a huge breadth of science that you can do. So if you have Meerkat data or someone who's got Meerkat data, start having conversations about what can you do with that data that maybe wasn't the original science goal, because there's a lot of great information out there. For those of you who want to use the MGCLS, as I said, the dataset is now public. It was released last year. I'll give you the website here, and you can access the data from there. There's a DOI that's set up for that, and there's details of the paper on that website as well. So I'm happy to answer any questions, either now or afterwards. Thanks very much for listening.
Thanks, Kenda, for a lovely, fascinating talk, which kind of shows us how Meerkat is a fantastic discovery engine, especially for diffuse emission and other such features. Also, the power of legacy data, like you mentioned, for the larger community to use in other kind of studies, apart from what it was first intended to be. We have 5 minutes for questions, so I'm sure a lot of people have many questions. So what we can do is, let's first take questions from people at SAO, and then I will then call out the people on Zoom who have their hands raised. Please raise your hand on Zoom if you'd like to ask a question. So can somebody coordinate the questions from the auditorium?
I think great. Okay, there's a microphone coming around. Can you go back to my presentation? So I don't have the controls here. Or if you show me where to do it. Okay, there we go. Which one?
Go back to that beautiful picture of, there we go, of that galactic jet in the upper right there.
Yeah.
I understand the current AG and the jets coming from it. Can we have the picture back again? But what has happened before? Has that jet been active over on the right, turned off, the galaxy moved, turned back on again? Can you give us some physics of the complexity there of those streamers coming off the left, but particularly on the right? It looks like a previous activity in the jet which might have eaten everything and then been fed again after the galaxy moved. I'm just guessing. Could you please do some guessing too?
So you're absolutely right. This is an extremely complex system. In the paper, we didn't have time or the scope to go through all the details. There is a follow-up paper led by Larry Rudnick that's focusing on this source. So these are both cluster galaxies. So at the center of quite a massive cluster, fairly low redshift. But in terms of the physics, I don't have any really good guesses for you. I'm not typically a radio galaxy person, but yeah, there's lots of signs here of things that perhaps you have iterations of activity from the jets. The right-hand source is very confusing to me just because of the directionality and then the crossbar. I'm not really sure how that would be generated. I mean, it initially looks like a head-tail galaxy, so the plume that goes sort of south-north, okay, fine, maybe, you know, that's dynamic activity within the cluster as it moves through the environment, but that crossbar, I actually have no good guesses. I'm not sure how that would be generated. So these are the magnetic filaments that I mentioned. We've got some nice polarization images that I don't show here. So these are within the cluster, yeah. No, not necessarily. So these are, most of these clusters are out of the galactic plane.
No, it's okay. I take care of that.
Okay.
Else we have a question? Okay, let's Z to the. Wait, sorry. He has a mic. Go ahead.
I just
Patrice.
wanted to comment on the filaments you're talking about.
Sure.
They are mostly generated from compressed magnetic field within the cluster itself, and then the accelerated particles get coupled into them to create that filamentary structure you see. So it's not from the magnetic field of the radio galaxy. The filaments going almost perpendicular in this direction come from synchrotron emission that is created from particles that get coupled into the intragalactic magnetic field. Yeah.
There's one more question from the room here, and then we'll go back to, and also perhaps a second question if there's enough time, Nirouj, and then it's back to you with the people on the chat.
Yeah. So let's take a couple of questions from the room, and then we can go back to Zoom.
Yeah, you have no question? Okay, fine. Then we have a last question from the room, and then we'll go back to you, Nirouj. Yeah, Mirjana.
Thank you so much, Kenda. Yes, my question is quick. What was the selection criteria for the last survey for the legacy survey that you mentioned?
Yeah, so they were.
So the redshift, but how did you select the clusters?
Sure. So they were, as I said, there were two sort of subsamples. There was a radio selected, which was makes up about a third of the cluster of the sample, and that was basically taken from clusters that already had been observed in the radio. Specifically, we wanted to look at things where we knew there was diffuse emission, and see what Meerkat would see in those cases. But there were also targets selected that had no detection at a different frequency or with a different instrument. And in some cases, we have found new emission that wasn't seen before. And then the other sample is X-ray selected. It's taken from the MCXC catalog. Again, there was a luminosity cut done. I can't remember the value off the top of my head, but you can see the luminosity range there on the plot. And it was basically luminosity selected, and then targets were taken from that pre-selected sample to fill gaps. For a lot of them, there is multi-wavelength in terms of, there's definitely optical data. Some of them only have DSS, particularly the very, very southern ones. But for the most case, you've got usually SDSS, sometimes even DES or decals. I think about 70% of the sample have X-ray data from Chandra or XMM. Some of them, there's only ROSAT, but with eRosita coming online, or being able to get their data out, that'll also fill in those gaps.
Thanks, Kenda. So let's move on to, so Prosperi Simpemba has his hand up. Prosperi, please unmute and ask your question.
Okay, thank you for that nice presentation. My question is on the cluster measures. I'm thinking that this could be a very slow process for a complete measure to take place. Can be corrected if I'm wrong. So I'm wondering whether in your studies you have actually captured a cluster measure, and is it possible to get information about past measures of clusters?
Okay, I think if I'm understanding your question correctly, you're talking about the time scale of a merger, and can we actually probe that and different maybe epochs of merging within the same system? So with the radio, that's a very, very interesting question. It's something that we want to see if the radio can open a window on. In the X-ray, for example, you might be able to see different epochs of merging, or maybe different directionalities if you had different substructures. In the radio, we can probe merger timescales. There's been some really nice simulations done of X-ray and radio emission by Donnet et al., I think it was 2013, which basically showed how diffuse emission might be expected to change throughout the lifetime of a merger. you know, and you can see the change in the X-ray as well. And that's been very useful in matching to real observations. So trying to see when in the merger are we capturing the system. But in terms of using the radio to trace different epochs of merging within the same system, I'm not sure that has been done. It'd be very interesting to see if that was possible, but I'm not sure that's been looked at yet.
Thanks, Kenda. So we're slightly running out of time, so we'll stop here, and I urge any of you who have other questions to go to Slack and chat with Kenda there, and where she can kind of continue taking your questions. Thanks again, Kenda, for a lovely talk.
Thank you.
Yeah. The next two talks are on outreach, and in fact, they're complementary. The lovely initiatives in Africa to have a newsletter or a magazine for popular astronomy, one in English and one in French. So the first speaker for this would be Unati Kondile, who is the editor of the African Science Stars magazine, and he's going to talk about boosting African astronomy in the media. I'll tell you after 20 minutes. Unati.
While we wait, I was sitting there trying to interpret how I can write Kenda's presentation in a news article, and I'm still, yeah, problems we face in journalism. Is it on? Yeah, that's on. Okay, so my name is Unati Gondile, the editor of African Science Stars magazine. I'm sure you might have seen copies of it when you came in here on the first day on Monday. It's a magazine that we started last year, but Science Stars as a magazine has always existed for a very long time, since 2011. So I'm here to speak broadly about, you know, some of the challenges we have as journalists or people working in the media, and then solutions in terms of how do we actually work and develop the agenda that I came and heard being repeated here by NRF as well as the president of AfAS. You know, you want to increase the number of African journalists or African students or people or Africans doing astronomy. So, I got this right, okay. That's the African Science Stars magazine, the latest edition. We're working on the next one, covering all ranges of matters from astronomy to space sciences. And we talk to a number of people there, and we try to really simplify some of the things that, you know, we encounter. So as we sit here, we're trying to de-jargonize some of the things that you're talking about, make them simpler, make them much more understandable and accessible. We've noted that indeed, astronomy is a beautiful science, but we do need to find ways to make it sexy and sell in a journalistic context. So in doing my research, we've had a dwindling number of science journalists in the country. It's a dying profession. You know, no newsroom has a science beat or someone who is assigned to do or speak on science journalism in that particular newsroom. And why is that? You know, where are the associations that used to exist? The African Federation of Science Journalists, the World Federation of Journalists, the South African Science Journalists Association. I think that has about 800 members on Facebook. So there are all these federations and associations that have been formed to sort of save science journalism. But we're not seeing an improvement there. And then the poor quality and quantity of science stories, that's exacerbated by the deficit of formal training. How many universities in this country do we actually know that offer science journalism as a course? Perhaps people do it at a postgraduate level. So once they've done their undergraduate BA journalism, they then go on to do postgraduate studies in astronomy or, you know, science journalism or writing about physics and all those other areas. But that is not enough, because you're then working alone. You're not being trained on how to do it. So something that I normally propose and that we've been doing as the African Science Stars magazine is going to communities and finding people who are working and are already astronomers, working in these fields and teaching them the basics of journalism. I think the future of journalism will rely heavily on us training people who are already trained in the field of study. So a medical journalist will have to be someone who has studied medicine, or a finance journalist has to be someone who has studied finance, accounting. Similarly so with astronomy. We need to now get to a point where we identify people in this room or online, or who are in, you know, the circle of African astronomers, who are interested in now taking this and writing about these things, and not necessarily saying journalists will do it. A journalist will write about this. It's a bit much more complicated than that. I've been here for the past 2 days, and I've watched and listened to presentations, and only a few, I took a few only that I could literally write about and simplify. Scientists don't like us. Live with that. You know, they really don't like us. Some treat us with disdain. We're not trained in the sciences. We don't know some of the terms and, you know, the intricacies of what you are dealing with. You know, I was listening to the discussion when you were trying to analyze if a jet had gone past a certain area of that. I was like, I would have never, ever, ever thought of that as a journalist. Hence, we do need people who are trained in this to be working on it. And sometimes we find that for us journalists, it's much more harder for us to unpack these concepts. I think Niraj, who's chairing this session as well, we work with them closely. So sometimes we do send the magazine to them to view it as a scientist. And I promise you, a scientist or an astronomer will find those mistakes, very small mistakes, when you look at it as a journalist, things we would call hostile. No, let's not capitalize this. No, let's not do this. But they will pick it up and they want it to be corrected. So there is that tension between journalists and astronomers that we need to strike a balance in. These are some of the things that were trending when I was looking at, you know, doing some research around what I'd like to talk about. And most of the things we spoke about here have not really come up. These are things that are trending on Twitter, on The Atlantic, on newjersey.com or space.com, various websites, the ones that are really leading. These are the things people are engaging with. And by trending, I mean that they have higher hits. There are more people reading them. So we have to look at these trends and then translate it into why is a story about perhaps Namibia's program, the outreach program that's happening in Namibia, why is that not trending? Why are these ones trending? You know, black holes, the major African radio telescope, you know, and that's the nature of news. For me, I understand why those are trending. It's a case of people want to read about things that we tend to say, if it bleeds, it leads. It's not news if a dog bites a person. So, you know, if the sun sets, it's not news. But if a person bites a dog, it then becomes news. So we're always looking for these angles, and we're always trying to find these angles in the things that you present. So the future, what happens then? How do we increase the number of Africans in astronomy? And I propose the media. As African Science Stars, these are the platforms that we should be gunning for. Magazines, we've got African Science Stars, we're doing that. Community newspapers, we're not seeing a lot of that. And every single country in Africa has its batch of community newspapers throughout the continent. Then we've got cartoons and comics. And I'll show you examples of these: children's books, textbooks, digital websites. There are quite a number of websites when it comes to astronomy. And they attract their own circles, but you tend to find that the interaction and the discussions there don't necessarily, they don't have numbers, they don't attract numbers. Radio, are we using radio? Television, film, are we using that? No. These are some of the community newspapers that we have here in South Africa. Some of them do cover astronomy or science news. But if you look at the bigger picture, only 2% of editorial or newspapers or magazines are dedicated to sciences, just 2%. And in a recent survey that was done, well, not recent, in 2020, 1,400 people were interviewed randomly across the streets, trying to find out, would you like to read about science? Why don't you read about science? Why don't you read about astronomy and those things? And 40% of those respondents said they're not interested in that. You know, cartoons, Dazia Nono. And these cartoons are special in the sense that they were done in the vernacular, in isiZulu, by a group of young people in Grahamstown and in Durban. So they start finding these terms for the galaxy, going to space, space travel, and they would include it in a community newspaper every single week. And that's where you pique the interest in things like astronomy. You start it and you find people from their early childhood and you instill that sense of this is an avenue, an option for you as you grow up. You don't have to just be a doctor. You can be an astronomer. So that was quite popular in Asia and Nono. I don't know if they still do it. This was way back in 2015 when they were doing it, and I used to see it regularly. Social media, I think one of the bigger ones is that astronomy page on Facebook. They've got about 361,000 members, followers. But if you look at the engagement, it's so low. People are not engaging with the posts. So you wonder, only 5 comments on this is the latest thing they posted, NASA's SLS Mega Moon rocket is ready. It's only got 5 comments, 9 reactions, yet there are 361,000 people sitting on that page. Why are they not engaging with the content? And they're updating regularly. So updating regularly and just having Facebook pages is not enough. You're going to have to put content that attracts their attention constantly. On the side, there are some of our tweets. I don't know if they're visible to everyone. African Science Stars was tweeting on Monday, and we found that these two traveled very far. They had higher numbers. They were going above 2,000 in terms of, at the time, circulation of theirs, number of hits. So Prof. Fulufelo Nelmaldo from the NRF, he was talking about Africans in astronomy. And there was also this one by Kevin Govender, where he said there are opportunities and they wanted, that also was shared widely and it also got a number of hits. So for us, we will use those insights to see what are some of the tweets and things that we were writing during the course of this conference that attracted a lot of attention to the wider public who are not necessarily trained or who are scientists. And almost at the end, this is something I'm really, really curious about. I'm a trained filmmaker, but I do newspapers and magazines. But this is an area we have not fully tapped into. There's this new movie, Moonfall. It's in cinemas right now. There are always movies about the earth ending, something hitting the moon, it's doom and gloom, aliens are coming, and these are because people are interested in these things. I think it was Prof. Memoni who spoke about the amateur astronomers and their knowledgeability of all these things. But in reality, these are very attractive things. Don't Look Up did quite well on Netflix. I don't know if you've watched it, but something's about to hit the earth and it's going to end, and it's all about that. Rising Star is a South African one, quite recent. It was shown at Izzigo, the National Gallery there in South Africa. And I think there are many more stories we can do. We need to find filmmakers, we need to find animators, we need to find comics, we need to find journalists, bring them in and to tell our stories. We went to Sutherland, when was it, 2 weeks ago, and walking in that town, there's nothing to do. Young people drink, their mothers drink, their fathers drink, and then there's this touristy side happening, the salt, and all these other telescope centers, observation centers around the town. Why not create a movie about a young person who grew up in the dusty streets of Sutherland, finding a job there, falling in love with a scientist, and going to work every day, and Can be a local little documentary. There are many ideas around these things, but to begin to attract people into this field, we have to create content that's appealing. It's not enough just to write and publish. It's not. There's also a documentary that's coming up, The African Universe. I think I'll share it with Charles and the organizers, the link. There's a link to it, the 24-minute promo, where they speak about the origins of astronomy in Africa. It's not yet out. It'll be out at the end of 2022. They've visited a number of places in Africa, and it really is interesting from the very short promo clip that I saw. It's got 3 episodes. But you can also Google it, the African Universe documentary, and something will come up. Extra reading for anyone who's interested in the field of science and journalism. It's a master's dissertation from a Stellenbosch University student. And there you will get a lot of insights. It uses South Africa as a case study, but you will get a lot of insights in terms of what is going wrong with journalism and the sciences, where the disconnect is happening. There, she speaks to a lot of people. She speaks to 20 journalists. She interviews a lot of people. She travels the world and she travels the continent as well, just to find out what's going on. So you can also just Google the current state of science journalism in South Africa, and you will get to see what her findings are all about. Yeah, I think that's where I end. Hope I didn't go over time. Thank you.
Thanks, Nati. Thanks, Nati, for a lovely talk about how important it is to have quality astronomy in the public domain in Africa and backed by strategy and policy. And also how important it is to have scientists who can engage with journalists and vice versa. So with that, we have 10 minutes more, so we can have a lot of questions. Let's, Jamal, if you can handle the questions in the room first, then we'll move on to Zoom. People on Zoom, please raise your hands, and then I'll call on them.
Yes, thanks. Thanks for the nice presentation. Also, thanks for the great outreach work you're doing, because it's quite important for the field, as anyone would agree. I just wanted to make a quick comment on the note you made. You said, well, we might need a documentary on a kid from here who studies astronomy. The documentary actually exists already. It's called Cosmic Africa, about Thebe Medupe. Well, it's maybe 20 years old by now.
Oh.
But something like that does exist.
Okay, thank you.
It's, by the way, worth a watch for anyone in the room who's interested.
Cosmic Africa. Okay.
All right. Hi. Thanks for the talk. But I wanted to comment something on the right here.
Yeah.
On advertising science to the general audience. As myself, for instance, I'm a science student. I'm already here. But for me, once the interest, didn't actually start by reading academic papers and all that kind of stuff. I started being interested in, for example, black holes and all those kind of new science things by watching YouTube. So maybe if we could get like South African YouTubers, instead of getting like guys from America to come and review things that are in Africa, but get someone from Africa, maybe create a platform for scientists, not necessarily maybe journalists, but science students to kind of review some of the things that Africa is doing on YouTube. It might kindle some interest, and then eventually someone might end up like me. Yeah.
Which publication do you work for? Or
sorry?
Which publication do you work for?
Do you write for? No, I am a student.
Okay.
Yeah.
Okay.
It's just that, what kindled my interest first was YouTube.
The YouTube channel.
Yes. But mostly it was American. That's why I'm like saying that it should be at least some African scientists doing the reviews. We've got a lot of cutting edge instruments, but most of the reviews are done by guys from outside Africa.
Yeah.
So if we could get a couple of science students, they don't have to be experts, just do a review on those things. I think that will kindle some interest.
If the people in this room don't do it, we'll do it.
All right, thank you.
Okay, so we have Donald who has another question. And then I think we'll back to you.
Okay, thank you. I'm just following up on what Michael said. That's what I was going to mention, is Cosmic Africa. The director of that, Craig Foster, lives in Hout Bay. Last year, his film, My Octopus Teacher, won the Academy Award for the best.
It's the same person.
He did Cosmic Africa, and then 20 years later, My Octopus Teacher. I know the situation with respect to the film and what needs to be done, so just talk to me privately, and I'll tell you where it is right now.
No, thank you. We need more. We need more of those things. Yeah, a lot more.
Any more questions from the room here? Okay, back to you, Neeraj.
Thanks, Jamal. Are there questions on Zoom? If so, you can raise your hand and I'll call on you. there's a raise hand option in the reactions button at the bottom of the screen. So while we're waiting, so we have quite some time left, which is great. So while we're waiting for some people to raise your hands on Zoom, let me ask a question. So your magazine went from a South African one to an African one recently, right, Unati? And so the main problem is access or reach. How do you get your magazine to various countries so that is well known there? And I know one thing you've all been doing is country roadshows, which I think is a fantastic idea. What are the other plans you have for making sure that the magazine is known in almost all the countries in Africa?
I think right now we're going digital. We're really switching to digital now and embracing that fully. And we found that it's gone further by being a digital magazine. We're printing a few for the places that we can reach, but digital has been a great platform for us. Yeah.
Okay, thanks. Other questions from Zoom? If you do not know how to raise your hand, you can just unmute and ask. That's also fine.
There's another question on Zoom. I can't see it.
Yeah. Are there other questions on Zoom? If not, are there questions from the room?
Yep.
If not, then I'll ask a question.
One more in the room, yeah.
Okay, please go ahead. Yeah.
Yep. Hi, Unati. It was a very great talk. I just want to find out, do you know what your overall reach is with Science Stars? That would be in digital and print media. Do you have an idea currently of what your reach is?
With digital, we're still measuring it because it's gone further than we ever thought it would. But with print, we're doing 10,000 to 20,000 copies. So usually you'd have to measure, multiply by 6 or 8, and then you would say your reach is 80,000 people. Right. Yeah, for the print version. But for the online version, that continues to surprise us. So we have to sit down and develop a methodology of trying to follow and track how far it's going, because we had a telescope competition and we had people who are sitting in China entering the competition, and people sitting, okay, there were people in Egypt entering the competition as well, but it went further than we thought it would go. So
and also just sorry guys, just one last question. I was wanting to find out, because I've seen a lot of great interviews that you guys have done, have you ever thought of maybe recording some of the interviews that you do with the people and actually post them as videos? Like he was actually mentioning now that some people are more interested in like YouTube videos and those and those sort of things. Some people don't want to read. Have you thought of maybe recording some of the interviews and maybe putting it up on a YouTube channel?
Yeah, we're going to do it. I'm looking at our chairman. We have to do it. We have to do it. I think the capacity, our human resources have been quite low. We don't have quite a big team, but it's not something that's difficult to do. We have to do it. Yeah.
Thanks, Sunati and Charles. There's a question on Zoom from the IAU OAD handle. You can just unmute and ask it yourself.
Sorry, it's me, Kevin. I should have changed the name on that. Yeah, I was just wondering if you could comment on the issue of cancel culture and, like people who express opinions online sort of being, how do you say in inverted commas, sort of canceled, and does that like discourage scientists from expressing their opinion and things like that?
It's very dangerous. That's all I can say. Cancel culture is extremely dangerous. And I think it's going to censor a lot of people from expressing their views. People are not going to want to make mistakes in public. I don't know how we're going to fight cancel culture, but yeah, it's very, very dangerous. It might limit public discourse and the number of inputs we get from people, because now people are all scared to participate in fear of being cancelled. Yeah.
Or just bullied, right? Yeah.
Yes.
So one last question, then we can move on to the next.
There's another one.
Okay, can I go? Okay. Thank you very much, Unati. That was really great. I enjoyed the talk. I just wanted to comment, maybe to ask also regarding the phrase that you put that scientists don't like journalists. Actually, I cannot really fully agree with that, because I think there are many of us who are very, very conscious about the importance of the common work and joint work, because without people who are communicating science, we can't do anything, So We need to do huge work regarding the public awareness. Outreach is one part of it, but it's not enough. And then communicating science to the public is fundamental. And we definitely need people who are then journalists, because also many of us, we don't know how to also properly, professionally communicate science for the public in general, no? So I think that there is a problem actually in the system, that there are no many journalists who are science communicators, no?
Yes,
Because
yes.
also then, you know, I think these problems come that very often because of the lack of the communication, and then very often the lack of proper information, that very often the things that are not scientifically really correct are communicated, and then that even increase the gap between the two. So we definitely need to work more together on one side to communicate together. So basically people cannot communicate science if they don't communicate before with scientists. And then we can also not expect, you know, that the science will be just communicated if we don't put as scientists our effort to reach journalists. And then the system actually we need many more people that are science communicators. So journalists that are, that do have a special, because it is a special formation, you know, that people have to go through, like how to really promote science, no? And I have to say that even in developed countries, it's a big issue. There are no contracts, I mean, the positions, stable positions, permanent positions that are related with science communication. And it is actually just starting now. So I hope in the future that will change, because if we look 10 years ago, even in Europe, there were no open job positions for science communicators, no? And now it is improving, but we are still a way ahead. So I think in Africa, this is something that we have to push, because we don't have job opportunities in Africa for science communication.
Yeah. No, I fully agree with you. I don't think I could add anything to that. Yeah,
So,
I fully agree.
Thanks a lot. We're running out of time, so we can go to the next talk. Thanks again, Unnati. And you know, let us remind ourselves that
Okay, thank you.
this magazine is our magazine, it's for all of us. So please do get in touch with Unnati and volunteer to write articles or interviews and so on. Let's make the magazine even better than it is right now. The next and last speaker of the session is
Actually,
Maram
Niruj,
Kaire.
there's a slight problem, because the next speaker, we could not catch him. He's not online, and obviously we'll have to somehow to make up for his time. So I just consulted people around here. I suggest, go ahead.
No, can I just ask if Salma Sila is here, because she also works on the same topic. Maybe she could say something about it.
Also, Catherine is there. I saw Catherine connected. She's also quite aware of the...
Which Catherine? She's in the...
So who are all familiar with the Astronomy Afrique magazine? Then we could just hear from you for a bit.
Okay, I will suggest the following thing. I mean, indeed, Catherine, if she is ready to speak about the... Donc, comment s'appelle, c'est l'Astronomie Afrique. There's also Selma, je crois, qui est avec nous, et moi aussi d'ailleurs, en fait. I am also in the staff of the magazine. Otherwise, or even we can join it to a larger discussion about scientific journalism, if it's not, if the time permit, so that we, unless Catherine, you can make a presentation that Maram cannot make because he's not here. Otherwise, we just we start discussing this French magazine, and we have Catherine who might speak.
Yeah, that's a good idea, Jamal. Let's do that. So
we
first,
can just branch to the larger discussion, and we are lucky to have Unnati with us, with the media person and also filmmaker, so we can discuss overall the general situation of the science journalism in science. Anyway, so
let me call on Catherine first. Catherine, would you like to say something for a few minutes about the journal, L'Astronomie Afrique?
Hi, are you talking to me?
Yes, I suppose, Salma, this Catherine Kohlenberg you're talking about, right?
Yes.
Okay.
Yeah. Hi, good morning. I just joined because I wanted to listen to Maram's presentation, but yeah, since he's not here, I can say a few words. L'Astronomie Afrique is a journal for French-speaking community in Africa. It is about astronomy, and it is for the wider public and as well for people interested in astronomy and astronomy students about what is happening on the continent in astronomy, and it offers also information about what constellations can be seen from the African continent. Yeah, and it's in French, so this was something that that was felt to be missing. I'm sorry, I'm totally unprepared to.
Of course, we understand. Yeah.
So there have been several issues published so far, but it's an online journal. There's an editorial board of which Salma and I are part. Yeah, we collaborate to propose articles. There's articles about topics that that are like the state-of-the-art astrophysics, with emphasis on discoveries that have been done in Africa, and at the same time also there are there's a rubric about cultural astronomy, a rubric about observations. So maybe Salma, you want to add some things to this?
I'm also in the staff of the editorial staff, if you recall. Just to say, of course, it's an online journal, and it is not a printed copy. It's also, I should say, an offshoot of the well-known French journal L'Astronomie, which is published by the Société Astronomique de France, which is a very respectable one. It has 150 years of existence. It was Camille Flammarion who created it. So people from the SAF, the Société Astronomique de France, thought that we should have something for the French-speaking Africa. So they made this Astronomy Afrique, but it's the online journal. And indeed, like Catherine has mentioned, there's many rubric, and some of the articles also are taken directly from the astronomy. The big, stuffy articles are taken right there. But also, it's open for the contribution from African astronomers. And maybe Sila, you want to say add something? Selma, you want to say add something?
Yes, just I want to add something. As I am an editor in this first webzine for Africa. Yes, for the webzine, every 3 months we have a publication about the rubric that Catherine already said, and the editor of this journal are from Burkina Faso, Senegal, Morocco, Algeria, and France also. And yes, what I would like to add is also the journal is about news from Africa, and to highlight what has happened in Africa about astronomy. Yes. Yes, and yes, every 3 months we organize prize to give telescopes in collaboration with the SSVI Star Shine for everyone. Yes, thanks.
Thank you, Salma. But may I also say that if somebody would like a brief translation of what is said in French, you can either raise your hand on Zoom or raise your hand at the auditorium, and we can ask one of the speakers to also, because this magazine is in French, and it will be good to have some of the material presented here in French as well, if people desire. Jamal, would you be able to handle that?
Sorry, what are you saying? Translation?
Yeah, if people want translation in French, they can. Then they can indicate.
The idea is not to be translated; it's to be into the French-speaking community. Because in English, there's other journals, in fact, like the African Star. So they could cooperate indeed in translating.
No, Jamal. I meant Jamal.
But not making it in English, I believe.
No, Jamal. I meant if somebody here wants a translation in French as to what was said in English.
So again, to be translated.
No. If somebody attending this session wants a quick translation in French. That was my
quick
question.
translation in French of what we said about the magazine.
Yes. Does anybody want
But
that?
it's just, I believe it's waste of time. I mean,
No, if somebody wants it, we
I
can
mean,
do
we
it.
are
If
not
not, we'll go.
into multilingual thing. You can just enter the site. Please, could you put on the chat the site of the journal? There's all the information there in French,
Okay.
and even you can get all the previous issues there. It will be smarter than the translating thing and going back and forth in French.
Okay.
So
yeah.
Selma, put it on the chat the link to the.
I'm not on Zoom.
Or perhaps Catherine, can you put
Catherine,
the chat?
Catherine is
all
there.
The content is there. In fact, for the past years or two. But there's a question also here on the room. So I don't know what if the issue is being settled. We can go to the questions from the room.
It is not a question. Just I'm going to comment and then have suggestions. Is there a way that we, the AfAS people, can design something to have our own magazines and also a television and so on and so forth, so that we can closely work with professionals and, of course, professionals. Otherwise, as I observe, even in my country, with little work, there are much pop-up, and with better work, there are, of course, the opposite. So I think we have to take action to have professional journalism around the profession. So I think the executive committee of AfAS shall take this comment to make at least an ad hoc for this proposal.
Thank you.
Again, can you just phrase in one sentence your proposal?
All right. I propose to have a media, our own media AfAS, that will balance the local journalism on astronomy and space science.
But you know, there is already such a thing at quite some extent. If you enter the site of the page of AfAS, do you sometimes enter the AfAS page? You will see a lot of news, I mean, in continuous mode, news about the latest discoveries, amateur astronomy, and so on. So just Neeraj can tell you more about that, or even Charles here. You just enter the site and you see so many news going on, and then Instagram, in Facebook, and so on. Just enter the site.
I'm saying that it has to work around the member countries.
Okay, Charles, want to say something about it? Yeah. Just take the mic. Just take the mic, Charles. Give you the mic. Charles is a journal editor, and he's a general. Sorry, he's a general secretary, and he's also taking care of the site and he's putting all the science content and everything.
So regarding information that's coming from AfAS and coming from Africa in general, we've got various platforms that we do that, right? We've got the website like Jamal mentioned. We've got our regular newspaper, newsletter that we publish twice a year currently. And we welcome articles that are coming from across the continent. Another thing, if you look at most of our AfAS branding, you will see that Science Stars is on most of our branding. Science Stars is actually a partner project to AfAS, which is being funded through the DSI, and in the same way that AfAS is being funded. So Science Stars also comes to us and say that where we are the astronomers that we can speak to. Can we get astronomers to send us articles? Can we get, because they're basically looking to be that voice for astronomers on the continent as well. So you could use the Science Stars platform through AfAS, or directly our newsletter, or any other of our platforms that we show on our website and so on. I think also Neeraj can add, and Jamal as well, if they have others.
Yeah, so I think AfAS has started multiple ways of reaching out to the public, and I think they're evolving. One is, of course, the website and social media, and others newsletter and so on. But I do agree that we need a lot more. I mean, given the size of Africa, we do need a lot more media ways of reaching out to the public, as well as specializing in the ways we have media, for aimed at school students or teacher training or general public and so on. And I think hopefully we'll grow as we grow along. They will also develop. One quick note. Sorry, Lawrence had a comment on chat for the GA LOC. So maybe somebody from the GA LOC could answer that on chat. Catherine has put the website link of the L'Astronomie Afrique, and Prosper is put in the website link for the Cosmic Africa documentary. So please do take a look at that. Meanwhile, maybe are there any questions, or can I ask a question?
This one extra thing from
Sorry,
Charles, and also have some comments, if I may.
I think just a comment. I really support what you're saying, Niruj, in that we need more and more platforms. However, we need to be very careful in that we do not start duplicating the things that we are already doing. Yeah.
So what might be good is maybe, I mean, there's a suggestion is that I know, I mean, the ASAP and Astronomy Africa meant to be pan-African initiatives, right? But then many countries have their own smaller astronomy newsletters aimed at school students and so on. So maybe good to kind of have a census of what those are and see if we can maybe work together in terms of having one story published on all of them, things like that. So that's something which we can do. I was wondering if somebody from the media committee is here and they can tell us a bit about what their plans are in the coming.
If to stay in the same tune to this thing, I may say a few things more in a more general setting about the multilingual Africa. And we, I mean, idealistically, we should have events, I mean, journals in other languages of Africa. We had yesterday Carolina who talked about the importance of having the content, science content in local languages. And I will say that there is, in Portuguese, in Swahili, we should get also this kind of journals. There is one in Arabic, by the way, that I am the science, editor, in fact, which is, I'm sending it usually in the African list, and whose main editor, by the way, will be in the next talk about Vasco. She is a student of medicine, and it's a great journal, which is now in its, and it is, if it's sent to everybody, it's in Arabic for the 12 countries with Arabic speaking in Africa, but I believe that because instead of translating, it's too harsh to translate journals, we should have Portuguese and Swahili and so on, encourage them to have their own journal, and that will be the smart way of doing it. In addition to cross-fertilizing, I was just mentioning that earlier, like myself in the Astronomy Africa, I keep sending news about the AfAS, what is going on at the level of Africa, and every issue or two I have these additions. And in our journal also, Shihab in Arabic, there's always a page on astronomy in Africa. So we should perhaps widen the scope, because it's impossible to solve there's so many languages in Africa, and there is not too, English is no go for most of the African young people. So if we think of, so we certainly have to go multilingual in some way, and that's what we are doing within the outreach committee. You Niruj, are quite keen in having all the news on the events taking place or phenomena, astronomical phenomena in all the major African languages. So that's just my little contribution. Go ahead, Niruj.
Thanks, Timon. I was wondering if somebody is here from the AfAS Communications Committee and they would like to say something about what you're thinking about for the future. Will there be Charles again?
Yep, there's going to be a talk about that generally on Friday, Niruj. So
Okay, cool. So we have some 10 minutes more, so we can still have a little bit of discussion on what we heard so far. Maybe we could have some discussion or comments on how do we segregate media depending on our various audience in Africa it is meant for. But before that, Katrina's raised her hand, so Katrina, please go ahead.
Yes, good morning. No, I just have a quick question to know whether what other publications there are in astronomy in Africa, if there is one that is maybe in Arabic, what's happening in Ethiopia, if there's Amharic publications, if there's a Kiswahili publication. I was just wondering if people in the audience know of other astronomy publications around the continent, and if that's the case, maybe we could sort of put them together and put all links to all of the publications together somewhere.
Yes, that's something I think we should do. That's very important. Yeah. Does anybody have any comments on that? Do you know of any publication? It could be a university journal or something very small scale, but then I think we should put them all together and support them for content. Is Nurali there? Can I ask him to say something about what he's been planning to do for many years for Kiswahili? Is Nurali there at Cape Town? Because he's not online. Okay. Are there other comments about Unati? Do you want to say something about in response to everything you heard?
Unati.
Sorry?
I do have a question for Unati.
Yeah, please go ahead.
Okay. Unati, I would like to understand what is the procedures that you guys in journalism use for employing people that write different sections, generally not just the journal or the magazine that you write for, because I notice in some of the newspapers in South Africa, many of them have no science content, as you highlighted. If you do want to cover what happens in science, you absolutely need to hire at least one science communicator. There are not a lot in South Africa. I don't know if Anton is here, but one of the key persons that I have known, Anya Furi, who was a key science communicator for Saral, I think eventually decided to move to NRAO in the US after some time. So how do you solve this problem of keeping science communicators, or at least creating new ones, or teaching and developing new people who would help you with science communication? That's one question. Just keep it in your mind. I will say something else. The second thing is your comment. I think Miriana tried to handle it a little bit, that scientists don't like journalists. That is incorrect. That is, it's my opinion, okay, that it is incorrect. One of the key problems is the way the communications between the scientists and the journalists go. Scientists don't know, okay, we probably do know, but we do not like long discussions and long meetings. The journalists love that a lot. I've done 3 press releases on articles that I wrote, one to Nature and 2 other ones. And it took, I think the Nature paper took 7 different meetings to agree on 1-page article that will go out to the media as a press release. And in the end, it didn't capture the science that I would like the public to hear. It's more tilted towards what the university wants to see. They want the world to see that researchers in their university are doing a great job. But the science, breaking down the science so that the public will understand what was done, was very, very minimal. So in my opinion, that level of friction, if I get a new science article tomorrow, I'm not going to the communications team again. I'll leave it. If people want to read, let them read, because they will take hours and hours of my time. And in the end, they put out something that, in my opinion, may not really help the common people to understand what was done. So how do you can come to us, you were at Northwest University, I remember you came with.
Sorry, we're running out of time. Can we have the question a bit briefer so that Unati can answer?
Yes.
Okay.
I said it's a comment, anyways.
Yeah. So Unati, please have a quick response. Yeah. Please have a quick response, Unati, and then we can break for tea.
So if you can comment on what you people would like to change to make it easier to communicate with scientists, that would be a lot easier. You'll find more people willing to speak to you. Okay. I think it's more of the communication strategy if you have responses.
Maybe I should have rephrased that statement about scientists not liking journalists. Scientists don't like how journalists work, the process of how we get to stories. Yeah, and how, yeah, so it's not necessarily the scientists themselves, it's the way we work and the way we're going to find an angle. We have to find an angle to sell your story. And it might not be what you want us to say, or that key part of your research. It might be something much more bloody or messy, something much more attractive that we're seeing there, you know. In terms of recruiting journalists, look, at present, that is the whole dilemma of journalism as a whole in the country. It's filled with people who are not professionals in all the things they write about. And that is why I proposed earlier that we need to find ways of employing people who are actually first trained in the profession and then training them in journalism. So either universities or faculties like the sciences can have a special writing course or, you know, a communication stream, just a short 6-month, 1 semester course where they just introduce you or get you into the news writing process. So you can also be able to do it yourselves. But there are very few in the newsrooms. Yeah, it's not something that makes money or sells a lot for us in the media, unless you're specializing in doing a magazine like African Science Stars. Then you know you have a specific audience that you're targeting with specific advertisers and donors who are going to support it. But for a newspaper or any other magazine to just include a science journalist and put them in there, it'll be very hard. It'll be very, very hard. And I think it's up to people to train them and also get them to also create their own YouTube channels, their own blogs, their Twitter accounts. Get your own following. Once we see that there's someone out there who's blogging about science or writing about science and they have a huge following, or they are a science or an astronomy influencer, then you're more likely
sorry,
to employ it.
Unati, sorry to interrupt you. The next session will start pretty soon, so you've been told to wind up. Can I request people to talk to Unati and other people on Slack so that we have a conversation there? So once again, let's thank Kenda Knowles, Unati Kondile, and the people who spoke for Astronomy Afrique and break for tea. The next outreach session will not be chaired by Salma as indicated, but be chaired by Priscilla Moheki. With that, let's close for tea and thank everybody.